All right. Hi, everyone. For this talk, I want to document the use of the pipeline as a code using the Jenkins DSL to generate a containerized deployment and test infrastructure for testing different versions of Puppet code for different customers. And that also helps us with transitioning from Puppet 3 to Puppet 5, but we're also using the same pattern for creating automated pipelines in Jenkins for Python, PHP, and Ruby stacks. This talk requires a little bit of knowledge of Puppet and Jenkins, but the concepts should be applicable on for other kinds of softwares which you want to deploy the same way, but where there might be some slight variations. And all doing this in a DevOps fashion. So who am I? Hi, I'm Christhope Vanlancker. I work at Inuits. I'm substituting actually my colleague Chris Buitard, who couldn't be here, so I took over his slides. I'm responsible for the internal ops team at my company. I also do some consultancy at customers, and I'm also a mentor for our new juniors starting to work at our company, so that making sure that they are trained and prepared for when they eventually go out to customers to do consultancy themselves. So, what are the goals? What are the things we wanted to achieve? So we use DevOps methodologies to automate things, to make our lives easier, our jobs also easier. And some of the things we do, we use Puppet for configuration management to help us deploy, prepare machines. We have different environments, and we want to be able to create them very quickly on the fly in a consistent way, in a reproducible way, but also if we need to make some improvements, some changes, that we are able to just with a couple of changes, not just apply those changes to the current way of building, testing and deploying, but that those changes are automatically also applied to all the other previous pipelines that we built to just build the code the same way. We want to do it in an automatic fashion, in a fast way, consistent way, and continuously. So I did mention DevOps, but what is it? There are a lot of definitions out in the world. It's not something that you can certify for, because it's a way of working, it's a set of methodologies that help improve how you work and also how you interact with your colleagues on a multidisciplinary level. And I think if you go and ask in different companies what DevOps means to them, you can pretty much describe DevOps with a set of acronyms, the CLAMs. So culture. DevOps is a movement which promotes collaboration and an open culture between developers and operations people. What does that mean? That doesn't mean that, oh, in a company you have developers, you have operations people, and then you have this mysterious DevOps team. No, that has nothing to do with that. Yeah, it's funny, but some companies interpret it that way. We have an ops team, we have developers, let's create a third team, DevOps team. That's not the way how it works. It means that you have your operations people and your developers talk to each other, plan ahead. Developers need to be aware of how operational people manage the infrastructure, so that they can, so they are aware in when they program, when they make that code, that they are aware that, okay, my software might not just run on one machine, it might run at scale, it might run on 10 machines, it might run on 100 machines, and that implies that that can have some impact, or it needs a different approach on how the way you program. And on the other hand, on the other side of the spectrum, ops need to know what developers are building, what the application is going to do, how it's going to behave, so that they can eventually also collaborate and make some adjustments to meet in the middle. Automation is also, oh yeah, there's the lean that I skipped. Well, the L stands for both learning, continuously learning and experimenting different ways on how to tackle a problem, but it also is the L for lean, because DevOps is actually an extension on an agile framework. It's a way of developing. More on that later. Measurement is also very important. When you deploy an application on an infrastructure, how does it behave? What do we need to monitor? What are the metrics, collections, feedback from that application, so that we know that not only if it's working, how it's working, see how it behaves and improve when necessary. Sharing is also very important. Sharing delivery processes across devs and ops. The way sharing, making sure that we use the same method of developing and promoting, and making sure that the developers and operational people are looking at the same, monitoring the same metrics, looking at the same thing. Work as one team for one goal. This is an example of what an agile framework looks like. So you need to plan, write the code, build, and test. And the DevOps methodology is actually an extension, adds monitoring actually to that. So usually you have the coding part, which is dev, and the ops takes care of release and deploy, but there's the monitoring feedback loop. DevOps also means that continuous delivery is an intricate aspect of it. So we like to use things as infrastructure as code, meaning that we describe our infrastructure as code, as the word itself says, and that has the advantage that you can test your code, you can write tests for it, you can automate your code, and that is actually also a dev's thing, actually, being able to do that. I'm not going to go much further on the DevOps side, because I saw that there was already a previous talk from Frederick about DevOps tools, which I really like. So if it's something that you would like to look further into, I'd highly consider rewatching his talk. So yeah, like I said, continuous delivery is very important, but what does it mean? We have usually 3 layers: continuous integration, delivery, and deployment. So what are those? Continuous integration requires developers to integrate code into a shared repository several times a day. That means that every time they check in code, that code gets picked up, it's tested, some other processes might be involved, and then the reason why you want that to be automated, and you want to be able to deploy as often as possible in order, with small changes, in order to detect issues much earlier and faster and be able to fix those immediately. The next step after continuous integration is continuous delivery. That means that your team is able to produce software in short cycles, ensuring that the software can be reliably released at any time. So being able to deploy as fast as, or as early as possible, to develop in a development environment for testing. Then after the next step after continuous delivery is continuous deployment. It basically means the same thing, but where there's continuous delivery, where once you have tested everything in development, you go to acceptance and production. Those are usually manual steps. Continuous deployment takes it to another level. Continuous deployment means that you very quickly already pass to production, but when doing so, you need to respect very strict quality gates. So your tests really need to be very strict, because yeah, of course, if you don't want to deploy buggy code immediately to production. So this is illustrated. So continuous delivery is you test stuff, and then through manual promotion you get stuff in production, while continuous deployment you automatically deploy to production when certain quality gates are being met. How many times a day? So at Flickr, they deploy to production 10 times a day. And that's really important because you shouldn't be afraid to deploy as often as possible to production. And you need, because you need to meet certain business goals. Your business wants you to, on one hand, be able to deliver very quickly, but on the other hand, they don't want stuff to break. But the fact that if your business makes the decision when to deploy, that shouldn't block you from making changes to the infrastructure, because whenever there's, like for example, a security bug, you have the responsibility to be able to fix that as quickly as possible, and you can't wait for. Usually, you shouldn't have to wait for a business decision to do that. So you need a reliable way to be able to do what you're supposed to do while keeping your bosses happy. So how do you do that? We have infrastructure as code. So you, because your infrastructure is described as code, you can test that. You can store that in version control. Test your cookbooks, manifest. So if you're using Chef or Puppet or Ansible or whatever, then you need a way to reliably deploy that to a dev environment and acceptancy and production. And also be able to monitor that. So what do? We version all the things. So our applications are versioned. The code to describe our infrastructure is versioned. The way we define our Jenkins jobs is also versioned. So let's take an example on how we achieve that. So this is an example of Puppet, what the Puppet code looks like. So we have some folders and files. What do? We check that out in version control Git, for example. So all those changes you put in version control, you see who made some changes and when. You can also revert some changes if you want. How many of you are actually aware of, how many of you use Puppet or are aware of it? Okay, so how many of you know about things like Librarian or R10K? Okay, so that's actually pretty good. So, so there are different ways of, going around your different modules in Puppet, which features to add or not. One of those are, for example, Librarian or R10K. There are some problems with those ways of managing your code. For example, well, Librarian is a ugly shell script. You need to make changes there. It makes you fetch changes straight from the internet, which is not very secure or recommended, and it's also a bit hard to automate. And it's also, you get in some situations where, you want things to go faster or want to make changes manually on your Puppet master or your Chef server. Not that good. So now, reasons why to not use things like Librarian, for example, is that you can actually achieve the same things with Git submodules. So there's an example of how you would manage the different version differences between Puppet modules. Oh, that's, let's see if I can make that a little bit more. No, I can't because it's an image. Never mind. But so the right image is what your different versions of your Puppet modules would look like in Librarian. So you have the name of your module, some link to where it comes from on GitHub, and then a reference to a specific checkout of those modules. And on the left side, you see the output of what it would look like in Git modules. So actually, you don't even need a librarian for if you want to do release management of your different Puppet modules. It's just in there. So yeah, release management is hard. Yeah, basically, like I said, you don't really need librarian or RTNK. You can do it perfectly fine with Git submodules. Yeah, so testing, etc. What we use, so we use Jenkins. So Jenkins is a tool that helps you automate your processes on how you build software and how you deploy it. There are a zillion plugins for it. So what does a pipeline look like? So usually you have a job that fetches your code from a repository. You do some tests in it, then usually you can package it and then deploy it. So this is what it usually looks like on our infrastructure. So for syntax and style, initially we check just all the code all the time, but as your code base increases, those tests run a lot longer, and you can then switch to a point where, okay, instead of checking absolutely everything, you only check the difference between the previous successful build, so that allows you to get your testings a lot shorter, and you're being able to deploy a lot faster. You could also use some Git hooks to even before your changes reach Jenkins, that you already have your code tested locally, so you can just quickly make some adjustments even before those changes reach Jenkins. We package all the things. Why? Because when you package, there are several advantages over just deploying a tarball or a zip file or whatnot. The advantage of using packages is that, for example, all the files that you've tested are hashed inside the package. So your package contains a manifest with all the files that it has, and that allows you to audit it. So for example, if you have situations where okay, there's some weird behavior or there's some code present that has been deployed which isn't supposed to be there, you can verify if those files have been tampered with, for example, because then the checksum doesn't matches what's in the manifest of the package. So we package the application code, the infra code, and if you're using a configuration management tool like Puppet, it's very easy. You just say package, the name of your package, ensure present, and it gets installed when it's in the repository. So yeah, also be able to deploy your code consistently. So one of the tools that we use to package is called FPM. It's made by Jenkins DSL. It allows you to just specify, hey, I have a directory which I want to package, and I want to package it in an RPM or in a Debian file. It allows you, it's not limited to that. You can also use it to package Ruby gems, Python modules, NPM, those kind of things. So it really, it allows you to package easily, get those advantages from using your package management system without having to learn how without having to learn all the specific stuff on how to create an RPM file based on a spec file, etc. In the end, it's not really packaging. It's an immutable branch that you're creating for your software, and it allows you to trace your release artifacts. We also use the same Puppet scripts, so we use some scripts to help us perform different tests for the Puppet code. Jenkins just checks that out, and then those commands are available for executing. The next step in our pipeline is upload to a repository. So we use, when we have our generated RPM, we upload it to a repository so that we have an archive of the artifacts that we built. For repository management, we use Pulp, but there are some other repository software out there, like Aptly or PRM. We use Pulp, not just because we are CentOS-based, use CentOS, but also Pulp allows us to just store the packages once on the system, but we can generate other, how to say, snapshots of the same repository. So for example, you download the CentOS repositories, the base, updates, security, etc. You pull that once, and then you can make a snapshot of those for different environments. So you can have staged repositories. That way you can have, if you have one environment where you just update, you copy all your packages there, you update all your machines. The idea is that your testing servers and your production servers don't immediately see those updates. You can update all your packages in your development environment, test there. Once all those updates have been tested and everything still works, then you can copy those and make those packages available in your acceptancy environment, update all your machines there, see if everything still works, and then when that's been verified, you can then copy all those verified packages in and make them available in production in a staged way, without every time duplicating all those packages, because Pulp just stores the files once on disk and then creates, I think it's hard links or symlinks that it uses in the backend. So this is the same explanation that I gave. So this is a visual representation on that. And then you can also have like an upstream repository where you dump your files, and then you can also go through that same cherry picking process. I want those updates available in this environment, etc. There's one problem that we encountered while using Pulp and uploading our packages to it. Managing repositories is slow. So it used to be that our pipelines were a bit slow because of the uploading of our packages to Pulp. So what we did is, okay, we want our software to be deployed as fast as possible. So this is actually a parallel job. We have on one side, we do the deployment immediately, but in a parallel job, asynchronously, we upload our package in a repository, which might take some time, but at least we can deploy as fast as possible. Now, why is it important to still be able to have those packages inside a repository? So when you deploy to Jenkins, your packages are already there. But what if you have to, for some reason, destroy a machine, recreate it? If you recreate your machine, okay, Puppet reconfigures everything, but you need your software from somewhere. So your choices are either you re-trigger the deployment, which re-triggers the deployment on all your other machines, or you just simply say, okay, you just fetch the latest version which is present in your repository, which your pipeline has in parallel already uploaded. Next thing we do, we also check the Puppet runs to see if everything is tested, and we also automate our monitoring. So every new host that we deploy, Puppet automatically configures the monitoring to view that. Also, metrics are collected automatically. Next step is the promotion. So we already deployed to development. How do we promote that software to the next environment? In the past, we used to use something called the Promotion plugin in Jenkins. So what it does is it generates a page with buttons that you can click on. The problem is we are not able to. It's not possible to describe that process in code. Why? If you know a bit something about Jenkins, Jenkins writes XML configuration files. Now, because it's a file, it has a certain structure, we can automate that. Problem is that plugin doesn't write a configuration file. So the annoying thing is that while we can automate pretty much everything in our Jenkins pipeline, exactly that job we can't do. That's why we abandoned it, and I'll show you in a moment how we solve that problem. So what kind of pipelines do we have? Usually when you have, you can have the same way to deploy Puppet code, but there can be some variants like a different name of environment, some different targets, that kind of stuff. What we want to avoid is, so in the past we described one pipeline. Okay, perfect. We use that as a template. And what we did was, okay, I already have my structure in Jenkins. I'll just use the function to copy jobs, existing jobs. Now, that worked in the beginning, but over time we saw that with each new project, we have some time to improve things. So just some little things there to improve. The problem with that is that your old pipelines don't get those new changes, those new optimizations. So in the end, you end up with your latest projects have all the improvements that you added, but your legacy projects still use the old methodologies, and it becomes more difficult to manage those. So nowadays we're able to do something like this. Create all these jobs with just a couple of small pieces of snippets of information, like this is the project, these are the targets, these are the kind of tests that we want to do, and Jenkins automatically reconfigures, not just adds the new project, but if you make those changes, it propagates those applies those changes to all your other projects in a scalable way. So in the past we did that through by templating XML, but after a while it got pretty tedious because some plugins write their versions in your XML, and that gets very annoying because every time there's a new update for a plugin, you need to change those versions in your XML. That was very troublesome. We also explored the use of the Jenkins Job Builder. So that's a Python-based tool made by the OpenStack folks. We saw that it had some limited functionality. Certain, like for example, manually triggering a job was not in there. I tried to submit a patch for that, but it took way too long for them to accept it, and eventually even OpenStack abandoned it. But that was a time where also the pipeline DSL stuff was coming up, so it was kind of waiting to see which solution would make more sense and get more adoption. So after a while, also the pipeline DSL appeared. Basically works similarly to how Docker files work. So you drop a Jenkins configuration file in your project, and Jenkins would detect that automatically and build the pipeline for you. So this is already an improvement. The only problem with that is that, well, it's the same problem as before. For your new projects, you tend to change some things around, but those changes you still need to like copy them around in your other projects. And the next step that we wanted to solve was actually have some kind of way to share the concept of the pipeline over different projects. So no more editing every configuration per project base, but just make sure that all projects use the same configuration globally. And that's why we started using the Jenkins DSL, Jenkins Job DSL. So it's Groovy based. So you pretty much script or describe the way you want your pipelines to look like in Groovy. And you basically feed it to Jenkins. And based on that, Jenkins is going to configure itself. I'm going to show in a moment how it looks like. So we have a concept of what we call a seed job. So it's a kind of a one Jenkins job that rules them all. We define just in a Groovy file how our project should look like, and we feed the data into it, and based on that, it's going to generate the rest. I'm going to show you how that looks like. All right, cool, we can see. Is it visible for you, or do I have to make it bigger? I think it helps if I increase the size. So I'm going to scroll down, and I'm going to point you to this one job called root. This is the one Jenkins job that generates all the others. So what it does is, and you can already see here, this job is responsible for generating a number of different seed jobs. I'm going to concentrate on this one, the puppetry seed job, responsible for generating the pipelines of all our Puppet code. So this is, let's see, I'm going to show you how the configuration looks like. So you basically just check out the repository. I'm going to show what's inside there. And you basically tell Jenkins to execute all Groovy files it finds inside there. So I'll show you the workspace. So in here, we just have one Groovy file. And what this says is, so I import, still visible? No, I'm going to increase the size. This is just a little library that helps Jenkins be able to parse YAML files through Groovy. What we do is we tell, using the Jenkins Job DSL, create a folder called Seedjobs. So if I go back, you can see here this folder called Seedjobs. So that makes sense. Awesome. Let's go back here. Then we load in a YAML file that we're going to use to configure our projects. We're going to define a map, load in YAML, and then we tell Jenkins to iterate over every project it finds. So what it's going to do is it's going to create a job inside the Seedjobs. Is it still filled? Yeah, also. It's going to create a job inside the Seedjob folder with the project name and then some prefix or suffix, and then some configurations for it. Configure Git, configure a trigger, and then it's going to execute whatever Groovy file is inside there. These are some actions on this will tell Jenkins what to do if certain jobs are not described anymore. What does it need to leave unmanaged jobs, or just does it need to purge the old ones? So usually what you want is to purge them in order to keep a clean view. So what's inside this this YAML file? Yeah. So this is an example of what's inside here. So here is a reference to different kind of projects. So as you can see, it's we have a project title, a Git repo, and a branch. So you are able to test your pipelines in on another Jenkins box, a development box, for example. And once your the description of your pipeline has been tested in development, you could update the pointer so that your Jenkins in production will use the new code. So this will create, so it's going to iterate over all these projects. So create a puppetry project, a dashing project, etc. So in this case, puppetry. No, pardon. It's going to create inside the Seedjobs folder, like I said, like a puppetry C job. So this one is responsible for looping over all the different projects. So as you can see here, we have a number of different projects. So those are actually, these correspond to Puppet environments. And they are, as you can see, they all have the same structure. We have a checkout job, we have some deployment jobs, packaging jobs, promote jobs, and that's all described through one Groovy file. So this is the root C job is going to create the puppetry C job, and the puppetry C job is going to fetch this. And here, for example, this one also has a configuration file. So git URLs, for example. Here we have the actual, oh no, this is for, yeah, okay. So for example, this is an example of an Puppet environment. It has a project's name, it has a branch, it has some stuff, and basically that's all you need. If you want, you can also add some more options to it, and then it depends on your your Groovy code to interpret what things to do with it. So I'll show you how it looks like. So this is the configuration. So here, this is the Groovy file responsible for looping over those configuration files and generating all the jobs. So again, it's the same concept. You load in a helping library to interpret YAML files. You load the configuration file in, and then we loop over all the projects. So let's say we have an environment called foo, for example. What it's going to do, it's going to create a folder called foo. No, pardon, yeah. Yeah, so in this case, the project name, the tree and the project name are the same by default. And then it's going to create a view. So I'll show you in a moment what that is. But here's the essential part, the job. So we describe here what our checkout job looks like, what it's supposed to do. Here we use variables which we added in the YAML configuration file, so that those values get injected in there for every project iteration. We do some stuff, a git pull. We check if there are some changes every 5 minutes. We do some cleanup, and then we trigger the next job, which in this case performs RSpec tests. We give it some conditions if it needs to, based on what it needs to succeed or fail. We have some rake tests, which are optional. So if for certain projects we want to have some different kind of tests, which we can enable or disable on a per project base. We can we can also configure which containers it should run, for example. So we have, in this case, 3 different containers. We have one for the current version of Puppet that we're using, so Puppet 3. But we also want to be able to test for the future. So we have already Puppet 4 and Puppet 5, and we want to make sure that those are all tested so we can choose against which versions we want to test. Yeah. So in the end, this will go through all the different projects, and in the end, you should get something that looks like this. I'll take. So these are all Puppet. These are all Puppet projects. I'll get the Inuits one as an example. Oh no, wait, I'm looking in the wrong one. Yeah, this one. So these are all Puppet projects generated from that YAML configuration file and Groovy file. And these are all the jobs that are generated from that. So here we have our checkout job, our tests in 3 different for the 3 different versions of Puppet, which run in parallel, and the one that we're currently using, Puppet 3, is the one that's blocking. So the other versions, they might fail or they might succeed, but the one that really needs to pass is this one, the one that we're currently using. Once, at least, if this one passes, then there's the next phase. We package the code, and then we deploy it to our Puppet masters, and in parallel, we also upload it to the repository. So I'm moving back to presentation. So yeah, using the Jenkins Job DSL, so we managed to automate the way we describe our jobs in Jenkins, and it's also yeah, it scales pretty well so far. So yeah, stop clicking, write more code. It's a bit hard in the beginning to do, but once you get you play around with it, Jenkins has a small Groovy sandbox where you can just add snippets of code and test what it does. And it takes a bit of practice in the beginning to use, but the nice thing about it is that you no longer need to configure everything manually by clicking in the GUI interface of Jenkins. You can just script everything in Groovy. You can also just spawn an empty Jenkins machine, have like a one-time action to inject your seed job, and that takes care of the rest. Yeah, really helps a lot. So if you guys are interested, we're also hiring. You can also always contact Chris Bertart or yeah, talk to any one of us from Inuits. So, are there any questions? I know it's pretty complicated stuff, but also to explain. But like, I don't know if you guys have a way that how you automate things in Jenkins, or no? Okay. Well, if you have any questions or would like to, yeah, ask some more, you can always ask me afterwards. So thank you very much for your attention.